Hello and welcome to Explore Release Recommendations and Provision and Test Environments. I'm Andrew Conniff, a Microsoft technical trainer specializing in data and AI. And in this session, we will explore best practices and recommendations for managing releases and provision and test environments. So let's get started with this. In release pipelines, understanding the delivery cadence and the types of triggers is essential for automating and controlling how software updates are released. There are three main types of triggers: continuous deployment, scheduled, and manual. A continuous deployment trigger automatically releases new builds as soon as they pass validation, ensuring rapid delivery and frequent updates. Scheduled triggers allow us to set up specific times for releases, which is useful for coordinating deployments during off-peak hours or aligning with business cycles. Manual trigger gives teams the flexibility to initiate a release only when they're ready, adding an extra layer of control for critical updates or special circumstances. Release approvals and gates are essential features in Azure DevOps, and they help teams control the flow of software deployments. Rather than dictating how a release happens, approvals and gates determine if a release should happen, adding a layer of trust and oversight to automated processes. Manual approvals allow the team to review and validate releases before they go live, ensuring that only thoroughly checked updates reach the users. Release gates, on the other hand, act as automated checkpoints. These can be set up before or after deployments to verify certain conditions are met, such as passing tests or meeting compliance requirements. This combination of manual and automated controls builds confidence in the release process and helps teams deliver reliable software more frequently. Now, release gates give teams additional control over the start and completion of the deployment pipeline. Think of the release gate as automated checkpoints that can be set up before or after a deployment. They ensure that certain conditions are met, such as the incident and issue management, or notifying users through calibration systems, validating quality, scanning for security issues, checking user experience against a baseline, managing changes, monitoring infrastructure health before the release moves forward. By integrating these checks, organizations can catch potential problems early and prevent faulty releases from reaching production. Release gates ensure that before a release can proceed, checks for critical issues such as new blockers, code coverage being below 80%, license violations, vulnerabilities or on the dependencies, or new technical debt have occurred. We want to make sure that doesn't get in there. And they also verify compliance requirements that confirm that the work items were linked to the release and check whether the release was started by someone other than the code committer. Or monitoring these factors, we can get release gates to act as a safety net, catching problems or criteria before they reach the users and maintaining the integrity of our software. A GitOps release strategy is a modern approach to software delivery that uses Git repositories as the single source of truth for managing infrastructure, configuration, and the application code. With GitOps, everything about our deployment, how our servers are set up, what versions of the app are running, and how our environment is configured is defined in code and stored in the repository. This means changes are tracked, reviewed, and versioned just like your application code, making it easy to see what's going on and to roll back if needed. Key features include declarative configuration, infrastructure as code, version control, and automated synchronization, all of which help the teams maintain consistency and reliability across the environments. In DevOps workflows, provisioning and configuring target environments is a crucial step for ensuring that software deployments are reliable and repeatable. Target environments can range from on-premises servers to cloud-based infrastructure, including infrastructure as a service, like virtual machines and networks, or platform as a service, such as Azure SQL Database, and even functions as a service for serverless computing. Clusters and service connectors are also part of this landscape, allowing teams to deploy applications across a diverse platform with consistency. By defining environments up front, teams can automate deployments, reduce manual errors, and ensure that every release is delivered to the right place, whether it's a test server, production cluster, or a cloud resource. In modern DevOps workflows, automated integration, functional test automation are essential for ensuring software quality and reliability. Rather than automating every manual test, teams are encouraged to rethink their test strategies, focusing on writing tests at the lowest possible level and ensuring that the test code is treated as product code. This approach means that tests are designed to run anywhere, including production systems, and only the most reliable tests survive over time. By making products inherently testable and aligning test ownership with product ownership, organizations can catch issues early and maintain high standards throughout the development lifecycle. The benefits of the strategy are significant. Automated tests speed up feedback loops, reduce manual effort, and help teams deliver robust software faster, but not all tests can be automated. And by implementing timely manual testing and integrated automatic testing into the release pipeline, we can confidently release updates, knowing that the applications have been thoroughly validated. Shift left is all about moving the quality checks earlier in the software development pipeline. So instead of waiting until the end to test, teams are starting to validate code as soon as possible, often right after changes are made. This approach combines process improvements and early testing to catch issues before they grow, reducing the time it takes to fix the problem and helping teams deliver reliable software faster. By performing unit tests, integration tests, and other validations upstream, closer to the developer, developers can spot the bugs and bottlenecks early, making the entire release process smoother and more predictable. Ensuring that our application is always up and running is also critical for user satisfaction and business continuity. Availability tests are automated checks that monitor the health of your application. They regularly test specific endpoints. In Azure, you can use tools like Application Insights to set up these tests, which typically include URL ping tests to verify the web address is reachable, and multi-step web tests to simulate user interaction across several pages, for example. By creating health endpoints in our application and configuring these tests, we can quickly detect outages or performance issues before they impact our users. The benefits of availability testing are substantial. Automated tests provide continuous feedback about our application status, allowing teams to respond rapidly to problems and maintain high reliability. And integrating these tests into our release pipelines means that every new deployment is validated for uptime, reducing the risk of an unnoticed downtime. Azure Load Testing is a powerful, fully managed service designed to help us understand how our applications perform under heavy traffic. Imagine being able to simulate thousands of users accessing our application at once. This tool makes it possible, allowing us to spot performance bottlenecks before the users do. By using existing test scripts based on Apache JMeter, you can quickly set up load testing without worrying about the underlying infrastructure. Azure Load Testing takes care of running our scripts and collecting the detailed resource metrics, so we can easily identify where our application might slow down or struggle as demand increases. We can automate regression testing by running load tests as part of our continuous integration and deployment pipelines, ensuring that every new release is validated for performance. Whether we're testing at the end of each sprint or in the staging environment, Azure Load Testing helps us maintain high standards for scalability and reliability. Plus, we can trigger the test directly from Azure Pipelines or GitHub Actions, ensuring our applications are readily available. Let's go to a demonstration and take a look at this in action. Notifications play an important role in DevOps. In Azure DevOps, we have 3 scopes for notifications. In the project settings, we can turn on and off project-level notifications. We can add subscriptions for different subgroups. This ensures that we have the right notifications to the right people. As users, we can further scope which notifications we receive. And at the organizational level, we set the behavior for notifications for all projects. Another type of notification is release gates. These notifications can be manual, to a person, or group. Our automated messages are handled by the gate controls. Here we see a manual approval being set up. Other pre-deployment conditions are checking Azure Policy, Azure Functions, Azure Monitor, work items, or calling a REST API. Pre-deployment and post-deployment gates provide full control of our release process. Multi-stage YAML allows us to perform all of our build steps, testing, and deployments in one file. Notice the modular file structures and we can combine these YAML files together. This makes deploying similar applications easier. Stages and jobs can run linearly or in parallel depending on need and resources. YAML is the format of the future, but classic release pipelines are still supported. However, for new organizations, you will need to turn on the permissions for classic pipelines in the organization settings. First, we add a source of artifacts for our release. This can be the output from a build or an image from a container registry or other sources. Once a source is added, we can create the stages visually. We can choose a preset stage or choose empty. And creating the stages here is straightforward, and we can clone previous stages. We also can use variables scoped to the stage to insert different values. We can easily arrange our stages to follow any order we need and easily make adjustments in the interface. If you'd like to go deeper and run the AZ-400 lab exercises using your own accounts and subscriptions, you can find the self-paced labs on GitHub at Microsoft Learning /MSlearn-DevOps. And if you prefer structured guidance, you'll also find options for instructor-led AZ-400 training with live labs and expert instruction on Microsoft Learn at the AZ-400 course page. This concludes our session. There are many ways to continue your learning journey. We encourage you to watch the other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.